Okay, so there's a few reasons why we might want to calculate the volume of our aquariums. We might be dosing medication, thinking about stocking levels, or even just curious, for example. So the first thing we need to do is measure the dimensions, and we'll use this tank as our example. So we can see that it's 24 inches in length, it is 12 inches wide, and our depth comes out at 14 inches. Obviously your tank might be different in any of the dimensions, but the process will be the same. So the formula that we're going to use is length times width times depth. And in this case it was 24 inches by 14 inches by 12 inches. That comes out at 4032 inches cubed. To find out what that is in gallons, we need to divide it by 231, which gives us 17.4545454544. We'll round that up to 17.5 gallons, and now we know what the total volume of the tank can be in potential, but it's unlikely that that is how much water you're going to put in there. To figure that out, we need a closer look at our dimensions. The width is going to remain the same, that's fine, but very few of us actually fill our tanks to the top. So we're going to assume that this tank is filled 1 inch below the top of the tank. Obviously that might be 2 inches, 3 inches, whatever. This is just an example. We'll say 1 inch from the top, and we're going to say there's 1 inch of substrate in the bottom of the tank. Obviously that's 1 inch at the top and 1 inch at the bottom that isn't filled with water now. So our length is the same as it was, 24 inches, but now our depth is 2 inches less than we had. We had 14 originally, now we've only got 12 inches in depth. So that's going to change things up when we put it into our formula. And I think you'll see that it will make a significant difference to our total. So the formula was length times width times depth, and now we've got 24 by 12 by 12 this time. That comes out at 3,456 inches cubed, cubic inches, sorry. And then to find the gallons again, it's the same, divide that by 231. So this time we have 14.96103, which will round off to 15 US gallons of water. So that's us saying that's how much water is in the tank, bearing in mind it's not full to the top and the bottom is full of substrate, be it sand, gravel, whatever. However, that's assuming there's nothing else in the tank, which may not always be the case. So now we need to have a look at what else we have. It may well be that you've got a nice collection of rocks that you got from the LFS over in this corner here. So that's taken away from our total volume of water, and we're going to say that we've got a nice piece of bogwood in the front here. And this is where a little bit of best guesswork comes in. Unless we're particularly scientific, we're not really sure of the volume of these rocks or the wood, so we need to guess. For the sake of this example, we're going to say that we think it takes 10% of the water volume being replaced by our rocks and our wood. So now we need to find of 15 gallons what 10% is. The easiest way I know how to do that is 15 divided by 100 gives us 1%, which is 0.15. And if we take our 1%, 0.15, and multiply that by 10, it comes out as 1.5 gallons. Obviously, you could have just done it by 10 in the first place, but if it was 15 or 20, it's a little bit harder to work out. So that's why I prefer to do it like this. And now we've decided that of our 15 gallons, 1.5 gallons is displaced by a hardscape, leaving us 13.5 US gallons. Now we're happy that we know the exact amount of water in the tank, and we can use that number for working out our medication dosage or whatever it was we wanted to know for in the first place. So although it looks a little bit complicated, it's not really. The formula was length by width by height, divide that by 231 to get our gallons, and then take off the percent that we think the hardscape uses up, if there is any hardscape. If you prefer to work in litres, that's fine. All we need to do is multiply our gallons by 3.785. So for example, if we're 10 gallons, we're going to have 37.85 litres of water. Makes sense, huh? However, in our example, we didn't have a 10-gallon tank. We had a tank that we said was 13.5 gallons of water. So we now need to multiply that by 3.785, which comes out at 51.0975 litres. We'll round that off to 51 litres. And obviously I'm no genius, I didn't work all that out myself. I used a calculator, with which you can do as well. Makes life much easier, eh? So once again, length times width times depth gives us our cubic inches. Divide that by 231 for your gallons and multiply it by 3.785 if we want it in litres. Easy. A couple of things to take into account. If you've got external filters like canisters or HOBs and you're wanting the total water volume, you'll need to add the volume that's contained in them. Alternatively, if you're dosing the likes of H2O2 and you're going to isolate them, you wouldn't include that. Also, if you've got thick glass like this, which is almost half an inch thick, you might want to measure from inside the glass. Otherwise, you'll end up with an extra inch each way in your calculation, which isn't actually water and is going to skew your results. And there we go. I hope that was useful. I hope it was easy enough to follow. I tried to do some of the calculations in different colours, you might have noticed, so if you want to go back and look again or pause it, it's a little less confusing. Like I say, I really hope it helped, hope it's useful, and I'm out. Later, 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 later.